Okay guys, if you have done it already, the first part, you should be getting the same number as me. Okay, 9, 4.5, 7.48, it should be around there. Because I cannot drag it very accurately, so agak-agak sama there can already lah. So you will get these numbers here. As for the last row, because there is no number, no number, no number, so every number will still be slightly different. However, if you are paying attention, you realize that if I change the length of my triangle, somehow when I take the ratio of the sides, they give me the same number. BC over AB, even if I change the length, it's still 0.5, the other one is 0.87, and the last one is 0.58. So you should be getting the same number also. Sorry about that. Okay, you should be getting 0.5, 0.87, and 0.58 regardless of what number you fill in. So please try to fill in your own number. Okay, depends on what triangle you use. Now, the second part here is asking you to compare triangle 1 and triangle 2 with this ratio. Okay, triangle 1, triangle 2. Okay, so let's take a look. Now, I want to have triangle 1. So you look at your GeoGebra. You have two triangles here. Use the triangle at the bottom and measure the length. Change the length according to what triangle 1 is. So since my triangle 1 AC is 3.74, I'm going to try to change it to as much as possible 3. We are okay, 3.74. Okay, that's 3.74. So that's my triangle 1. Then I'll change it to my triangle 2. My triangle 2 is 7. This is my triangle 2, 7.48. Okay. Triangle 2 is the one on top, so 7.48. I'm going to change it. 7.48. Okay, 47, close enough. So you see that once I change it, my ratio is. Do you see notice about the numbers or not? Of all the three ratios. Okay, you look at mine. It's all. They are all 0.5. So all ratios are 0.5. Okay, if you compare triangle 1 and triangle 2. So the one at the bottom is triangle 1, the one on top is triangle 2. Okay, then what can you conclude about triangle 1 and 2? If all of them, all sides, okay, you look at the triangle here, and the sides, I'm taking the equivalent side compared to equivalent side, AB over AB, BC over BC, and AC over AC. And if all three sides, when I compare the ratio, they are all 0.5, what can we conclude about them? Okay, we can conclude that the two triangles are similar. Okay, now do the same for triangle 3 and triangle 1. So triangle 1, you don't touch it, but triangle 3, your triangle and mine could be very different because it depends on what number that you fill in here. Okay, whatever number that you fill in here will affect your answer here. So everybody should get different answer, but you should still come to the conclusion that all ratios are the same number. So can you try to fill it out yourself? Everybody's answer should be slightly different. And then you can also conclude that the two triangles are similar. Okay, so what do you observe from the value of BC over AB, AC over AB? So in the table above. So from here, can you look at the ratio here? This one I just toggle on and off. Okay, so can you notice anything about these three? Okay, the ratio of BC over AB, AC over AB, and BC over AC are constant when the angles is fixed at 30 degree. You realize that if your triangle, you don't go and change the angle, right? No matter what length that you change, what is the size of the triangle? Okay, you can pause the video and go and see it later. So no matter how you change the size of the triangle, you see, no matter how I change it, okay, no matter how big, how small, what is the AC, AB, BC value, my ratio of all sides is fixed. Okay, regardless of how I do it, it's fixed. All right. So that's what you should notice. So what idea can you use to explain the ratio of BC over AB? Okay, they are similar triangle. When angle A is fixed. Okay. All right. Then after that, you will have the next part here. They want you to change your angle and drag the point C to vary the sides of the triangle. So for question number 7 here, I'm going to show it to you. So now they want you to change your angle. So can you go and change, like I want to use, I don't know, 45, no, 45 is a nice number. Let's choose a 42 degree here. Okay, now if I have a 42 degree, you realize that, hey, if my angle here is fixed at 30 for the triangle at the bottom, then you realize the ratio of all three sides are no longer the same number. I get 0.57, 0.42, and 0.66. Okay, so I vary the angle and then I see the ratio. So first one, according to question, I keep it at 30 lah, huh? Keep it at 30. Then you can just write down whatever number that you have into a table. Okay, the length of AB, BC. Let's say I try to fix AC to 4. Sorry about the drilling. Okay, fix the AC to 4, and then after that you just change the angle accordingly, and then you fill in the table, and then after that compare the 3 different ratios, and then I want you to write down your observation there. Okay, so you try to fill in the table according to the requirement here, and then tell me what do you see. All right, so you realize, what do you notice about the ratio? Okay, I want you to try to later we will come back to this later. Okay, we will move on to the next part first. So from here you have learned that the longer side is called hypotenuse, right? Okay, and then over here we are also going to learn that the one opposite the angle that you are using, which is, can you highlight with the reference to the angle A? Okay, the side opposite, we call it opposite. Okay, this is called opposite. And then we need to name the other side also. The remaining side is next to it, so it's the adjacent side. So we call it adjacent. So in this chapter, when we are learning about trigo, it is important for us to know how to name the triangle, okay? What is hypotenuse, opposite, and adjacent. Okay? So the one opposite my reference angle is opposite, longer side is hypotenuse, and the last remaining side, which is the one next to your angle, is called the adjacent. Okay, so let's practice. Turn to page 4. We need to identify and label the following diagram. Let's try. Okay, I'm going to do the first one for you. First one, always easy to identify. Hypotenuse is just the one opposite the right angle, and the one opposite my angle, reference angle, is opposite, OPP, and the last one is adjacent. Okay, I will leave the rest here for you to try out. You can refer to OneNote for the complete solution for this page. Okay, once you are done, you can move on and check the answer, and we will move on to the next segment.